Picture a frozen, radioactive wasteland. The surface temperatures here sit deep in the negative, creating an environment that closely mimics solid dry ice. Leave a living cell or a biological spore out in the open, and this harsh environment will instantly dehydrate it until there is absolutely nothing left. But in 2003, the European Space Agency launched a spacecraft called Mars Express to analyze the toxic atmosphere of this seemingly dead rock. What they found was a massive biological anomaly: methane. On Earth, the vast majority of atmospheric methane is a direct byproduct of biology. It is actively generated by living creatures, like cattle digesting their food. Finding that exact gas on a neighboring planet defied all expectations. It was the equivalent of finding fresh footprints on a world assumed to be completely empty. This chart plots historical methane levels in the Martian atmosphere. For an estimated 300 years, the gas hovered at a perfectly flat, steady baseline. Then, in 2006, almost all of that methane suddenly disappeared. To understand the physics problem here, look at the dotted projection. This is the expected slow decay of the gas. The actual disappearance happened roughly 600 times faster than any standard mathematical model could explain. Gases do not generate and evaporate at that speed by sheer accident. The sheer pace of the event suggests an active, powerful process currently operating out of sight of our orbital sensors. To escape the intense cosmic radiation bombarding the surface, researchers realized any ancient life would be forced to migrate. It would have to retreat deep below the Martian crust into dark, insulated layers. To test if biology could actually survive down there, scientists built specialized simulation chambers to replicate the exact conditions of Mars, right here on Earth. They subjected organic samples to the absolute extremes of the Martian subsurface: freezing temperatures matching dry ice, a complete absence of water, and immense atmospheric pressure. If organisms could persist under those exact variables, the dark subsurface of Mars transitions from a theoretical grave to a potential habitat. The chamber results were highly specific. Up to 6 distinct types of bacteria and fungi easily survived the simulated punishment. The toughest candidate of the group quickly earned the nickname Conan the bacterium. When subjected to rapid flash freezing and total dehydration, this single-celled organism immediately contracts and locks down its internal structure to protect itself. By entering this severe state of suspended animation, Conan the bacterium can remain viable for a staggering 280 million years. While geological shifts remain a possibility, the existence of such resilient microbes offers a compelling biological explanation for the erratic methane. It raises the prospect that the gas was produced by life that never died off, but is simply in a state of centuries-long slumber. Looking at the planet today, the barren red dust may be a deceptive facade. These findings suggest Mars could function as an incubator, potentially harboring dormant survivors just out of our view. Space agencies are now finalizing the hardware for their next generation of space rovers. These machines are designed specifically with heavy drills, capable of boring directly into that deep, insulated soil. The immediate scientific objective of pulling up those core samples is to attempt to extract these microscopic survivors. Doing so would provide definitive proof that Earth is not the only living world in our solar system. But removing a creature from a 280 million year stasis carries a massive biological risk. We are talking about an organism that literally evolved to outlast a planetary extinction. As we drill deeper into the unknown, our drive to find cosmic neighbors might result in pulling up an ancient, hyper-resilient survivor, one we are completely unprepared to wake up.